All right, here we go. I'll be honest about this one. Only just figured it out about 5 minutes ago, so no guarantees. So for the first question, we have to determine the value of x with the following arithmetic sequence. So we have x plus 1, 2x minus 1, and then 4x minus 9, and the sequence continues. So because this is an arithmetic sequence, we know that the difference between these two will also be the difference between these two. So these, whatever number, let's call this y for the sake of this example. You can use whatever variable you want. I'm just using this to explain it. The difference between these two numbers is going to be the same number. So because we know this, we can set them equal to each other. So t2 minus t1, so the difference, so basically that equals y, and the difference between t3 minus t2 is also going to be equal to y. So because these two are set equal to each other, we can set these equal to each other. So we can have t3 minus t2 is equal to t2 minus t1, and that's a valid expression. So now we should substitute in for what these mean. So we know that term 3 is made up of an a value, actually no, we don't even need that. What we need to do is we need to go and just steal the term. So t3 is 4x minus 9, then brackets, subtract 2x minus 1. Now that's equal to t2 again, 2x minus 1, put that in brackets, subtract x plus 1. All right, now let's expand. So 4x, actually we really don't need the brackets. So 4x minus 2x gives us 2x, and 9 minus the 1, negative 9 minus the negative 1 actually gives us negative 8, because we have the negative 9, and the two negatives cancel out to become a positive, so we get to 8, is equal to 2x minus x, so just a single x, and then negative 1 subtract 1 is negative 2. All right, now that we have this expression, we need to get the variable to one side and the numbers to the other. So we toss over x, which becomes a subtract, which means we just have x on this side, and then our negative 8 turns positive to the other side, and that means 8 minus 2, x is equal to 6. I'll throw in the 2x minus the x just to make it a bit more clear. All right, that's the first one solved. It's actually quite simple once you realize that the difference between these terms are the same because it is an arithmetic sequence. All right, the next one, not so sure about. This one's a bit trickier, but it is possible. So we have t2 plus t3 is equal to 84. We know this. And we have t5 plus t6. Is that on screen? I think so. Is equal to 2268. All right, now what does t2 mean in terms of the general formula? So we have, for everything, it'll be tn is equal to a bracket r minus n minus 1. So we can turn let's say t2 into a bracket r 2 minus 1, so to the exponent 1. So now let's put that equation, but with this inside of it. So we're going to use this bit. So we have 84 is equal to the t2. So what does t2 look like? Single a value with our r inside of it, 2 minus 1, because the 2 is our n value over here. And then we have plus t3, so we do the same thing for t3. So we have a bracket r, 3 because the n value is 3 now, and minus 1. So expand and simplify, 84 is equal to a bracket r to the first power plus a bracket r bracket to the second power. So we can factor this further. To do this, we have to realize that there are two a's added together. So we go 84 is equal to 2a plus r, because that exponent 1 just goes away, plus r squared. So we can't common factor out of this, but between these terms, we can actually common factor out an r. So what we do is we go 84, that's an 8, is equal to 2a plus r, because we factor, so put your imaginary brackets around here, we factor out an r, and then inside the brackets, we're left with 1, because 1 times r is just r, because remember, the 1 coefficient is just sitting out in front of there right now. So we have 1 plus our r. So if we were to expand this back, we'd get r and then r squared, which is what we have here. So now that we've factored this, this is one of our equations that we're going to use. Let's call this 1. Now what we need to do is we need to create the second equation. So we take t5, which t5 would end up being 2, 2, 6, 8 is equal to, so we do the same thing as before, a bracket r to the 5 minus 1, and then plus a bracket r to the 6 minus 1. All right, expand and simplify that out, and we get a to the, with r to the 4th power, and a with r to the 5th power. All right, so now we're going to do the same factoring trick that we did before, like in over here. We're going to factor the two a's together, so we have 2a, and then we're going to, I'm going to try it in one step to see if you guys understand, and we're going to factor these in one step. Actually, no, I'm not going to do that because that's complicated. R to the 4 plus r to the 5. So, between these two terms, what's common? We have 4 r's, let's just say that, 4 r's multiplied together, and 5 r's multiplied together. So we can pull out at least 4 r's from this expression. So we have 2, 2, 6, 8 is equal to 2a plus, we can pull out 4 r's, so pull that out, and we're left with r to the 4th root times 1 is equal to r to the 4th root, so we are left with 1 plus r to the 5th root. To make that possible, we have to make it equal to r. So now we have our two equations. Now all we need to do is I think it's divided by the 1, because it's a exponential linear system, which means we're going to have our 2268 is equal to 2a plus r to the 4. I'm going to flip the order in the brackets just to make my life easier. R plus 1 is all over 84 is equal to 2. I should probably make that equal sign in the same spot. Whatever, close enough. Is equal to 2a plus r, single r, r plus 1. So, because we're dividing this, if anything on both sides is the same, we get to cancel them out. So 2a can go. R plus 1 can go. Now we're dividing this. So 2268 divided by 84 is just going to be 27. Nice, simple, easy number to work with. Actually, oh, I just wrote that over here. Oops. Okay, so basically what I did was 2268, write out my equations on top of each other. Anything that's the same, we can cancel each out. So this divided by this is 27, and using our exponent laws, r to the 4 divided by r to the 1, let's put that there just for sake, 4 minus 1, because division is actually a subtraction of the exponents. We should know that, which gets us r to the 3rd power. Now to reverse, or to get rid of that 3rd power, all we have to do is we have to take the cubed root, and that gives us r is equal to 3, because 3 to the cubed is 27. So that means that r in this sequence is equal to 3. Now we can go back and solve for a. Bring it back to our, one of our original equations. So 84 is equal to 2a plus, let's sub in the value for r, so 3. Multiplied by 1 plus 3. So 84 is equal to 2a plus, so we've got 3 here, 3, this will combine to be 4, so 12. So to get rid of it from both sides, we divide off the No, that's incorrect. I'm just solving this here pretty much for the first time. So since it's a plus, we just subtract it from both sides. So 84 subtract the 12 is equal to 72, and then 2a. Then you divide off the 2, and a is equal to 36. Now that we have these two numbers, we can build it as if we would a standard series. Sequence, I should say. Sequence, not series. Different thing entirely. So t1 is equal to 36, because that's our a value, and then r, which is 3, to the power of, what is it going to be? To the power of 1, so that'll actually 1 minus 1. So t1 is equal to 36 times 3, or 36 times 1, because those cancel out to become 0. So t1 is just 36. t2 is going to be equal to 36. I'm suspecting that I did this wrong, which is unfortunate. Yeah. 36 to the third, because that'll be squared, because it'll be 2 minus 1. So to the 0 becomes the 1, to the 1 becomes the 3, so t2 is equal to 36 times 3, and then t2 becomes 108. And I'm beginning to realize that I did not solve it correctly. So